A curve is defined by the parametric equations here for theta between this range. Show that dy dx equals this. Find the coordinates of the point on the curve at which the gradient is 2. Show that the curve has no stationary points. Find a Cartesian equation of the curve, giving your answer in the form y squared equals f of x. So that's the question then. I've got it paraphrased here. So let's have a look at dy dx then for part 1. So dx d theta first then. Differentiate dx d theta, sine squared, something squared, 2 comes down, power rule, sine to the 1, multiplied by the something differentiated, sine differentiates to cos. Dy d theta then, differentiate sine, it goes to cos. Power rule, something cubed, the power comes down to the 1 less, multiplied by the something, sine differentiated, which is cos. So let's see what we've got then. So that's dy dx then will equal this stuff. There's a cos common on top. So let's take that outside a bracket. 4 minus 3 sine squared in a bracket divided by 2 sine theta cos theta. So that's equal to, the cos's cancel top and bottom, and we're left with 4 minus 3 sine squared theta divided by 2 sine theta. And that's what we wanted to show here. Find the coordinates of the point where the gradient is 2. So part 2. So when does that equal to? 4 minus 3 sine squared theta over 2 sine theta equals 2. So multiply, bring the 2 sine theta up. 4 minus 3 sine squared is equal to, bring this up from divide to times. 2 times 2 is 4. So it's 4 sine theta. Move everything on the same side, so move this over, so we've got a plus 3 lots of sine squareds. We've already got a 4 sine theta, leave that as is. Move the 4 over to become minus 4, there's nothing left on the other side. This is a quadratic. It has to be, let's hope it factorizes, it has to be 3 sine theta and sine theta. It's either 4 1s or 2 2s. I've got a feeling it might be 2 2s. And that's a plus, so this would need to be a plus and this would need to be a minus. This one has no solution. Sine theta equals minus 2 has no roots. So the only solution comes from sine theta is this one here, and that would be 2/3, wouldn't it? For the roots. And that's the only solution. So we can work that out. Theta, remember, goes from minus pi over 2 to pi over 2, so we're dealing in radians. So let's draw a circle. We're going from minus pi over 2 for theta to pi over 2. And we've got sine theta is positive, so that would be here. So we just need to do shift sine alpha. So theta, shift sine 2/3, shift sine of 2 divided by 3. Now we're in degrees, we want to be in radians. Number 4. And then work out the radian. 0.73 radians. And that was worked out to 2 dp. Okay, that's what we've got there. So that was when the gradient, the coordinate when the gradient is 2. So that's what theta is, and we've got it in our calculator. So we can work out x and y now. X equals sine squared and y equals sine, oh, okay. X equals sine squared, so we didn't need to work that out at all. Because x was equal to sine squared, which is 2/3 squared, which is 4/9. Y will equal, so I just blindly went on, not look at what the question actually asked for, because we just want the coordinates. So y is 4 sine theta minus sine cubed. So that's 4 sine theta minus sine cubed, wasn't it? Let's have a look at that. Yeah, that's fine. 4 sine theta minus sine cubed. Let's just work out that number. 8/3 minus 2 cubed is 8 over 3 cubed is 27 times by 9 top and bottom here. 9/8 take 1/8 is 8/8, which is 64 over the 27. That's the fraction. Tap it in the calculator. So the answer is the coordinate 4/9 and 64 over 27. And that's the coordinate where the gradient is 2. Show that the curve has no stationary points. Okay. So what part was this? Part 3? Or part 2? Part 3. No stationary points. Well, dy dx is equal to 4 minus 3 sine squared theta, I think it was. Let's go back and just get it. 4 minus 3 sine squared theta over 2 sine theta equals 0. It would imply this top part's 0. Which implies, in turn, that 3 sine squared theta is equal to 4. So sine squared equals 4/3. And that implies sine theta would be greater than 1, wouldn't it? When you square root both sides, you'll get a number greater than the modulus of 1. Or sine theta would need to be less than minus 1. Which is not possible. So no turning points, or stationary points rather. Okay, so that's that done. That's part 3. Now, next part. Find a Cartesian equation of this form in this form. So we just have to reduce it to Cartesians. X is sine squared, 4 sine minus sine cubed is y. So this is part 4 now. X equals sine squared. Y is equal to, what was it? I've got to go up and get it again, sorry. What was it? 4 sine theta minus sine cubed. 4 sine theta minus sine cubed theta. So let's get y squared. Now there'll be a 4, take out a sine as common here on top. And you've got 4 inside minus sine squared. And it's that term, which is this, squared, isn't it, if we square y. So that's equal to just sine squared. And then 4 minus sine squared, theta squared. So that tells us what y squared is then. Sine squared is x, that's why we're doing it. And it's 4 minus x squared. And there's our Cartesian equation for y squared equals